Welcome back to part 5 lecture of trigonometry basics. So if you want to find out trigonometric ratios of sine, cosine, tan and other values, you should know the two sides of the right angle triangle. Now we will see a problem consisting of only one side information and another relation. So which is an indirect problem. Instead of giving the two sides, we have only one side information to find the values of sine q and cos q. See the right angle triangle OPQ angle, right angle is at P. So at P, the angle is 90 degrees. And another two vertices are O and Q. So one side OP, let us take OP is equal to 7 centimeter and PQ is unknown. So if you know PQ, then automatically you can find out the hypotenuse and then sine Q and cos Q. But here only OP is known, angle is known, one right angle position is known. We don't know the other two sides. Now what have to do? How you can find out? So here OP is known and one more relation is provided, OQ minus PQ. That is the relation between the other sides that is provided to find the values of sine Q and cos Q. Now to solve this problem, I have relation. So I have to write a relation related to the sides. So in right angle triangle, we can take the Pythagoras law, which is hypotenuse square is equal to side square plus side square. So let me take the same law here also. OQ square, that is hypotenuse square, is equal to OP square plus PQ square. So this is the PQ square. Yeah, this is the this is the Pythagoras law. Now the relation is OQ is equal to 1 plus PQ. So instead of OQ, I can keep 1 plus PQ in the equation. So let me replace the OQ with 1 plus PQ. So if I replace OQ with 1 plus PQ, now what happens? 1 plus PQ whole square is equal to OP square plus PQ square. So now I will extend the 1 plus PQ whole square using a plus b whole square formula, a square plus b square plus 2ab. So if I write that 1 plus PQ square plus 2 into 1 into PQ is equal to OP square plus PQ square. Now PQ square term is there in both sides, so let us cancel PQ square. Now the rest is 1 plus P2 PQ is equal to OP square. OP square is 7 square, which is 49. So therefore 1 plus 2 PQ is equal to 49. Now 2 PQ is equal to 49 minus 1 becomes 48, and PQ is equal to 48 by 2, which is 24. Now I got the value of the second side, which is 24. Obviously I can find out the hypotenuse, which is equal to square root of side square plus side square. Now I can write square root of side square. One side square is 24 square, another side square 7 square. So which is equal to 25. Otherwise I can use the relation OQ is equal to 1 plus PQ. 1 plus PQ is 24. So 1 plus 24 becomes 25. So that is how I can find out all the sides of a right angle triangle. Once if I know all the sides of the right angle triangle, now write sine C is equal, sine Q is equal to opposite side. For this triangle, opposite side is 7. So 7 by hypotenuse will be 25. And cos Q is equal to adjacent side will be 24 and hypotenuse will be 25. So this is how I can find out the trigonometric ratios. This is the problem, an indirect problem where we don't know the values of two sides directly. We know the value of one side only. The second side we have to evaluate from the relation. So remember, no need to do the much computations. Only use the basic principles of ratios and the Pythagoras law to solve any type of problem related to the trigonometry. Even in sometimes we may know the value of one trigonometry ratio, and from that we have to find out, we have to evaluate the complex expressions. So in such cases, if you want to find, if you know the one value of trigonometric ratio, then you can find out the remaining ratios and we can evaluate the values of the complex expressions. Let me take such type of problem here. So, for example, I have a right angle triangle ABC where tan A is equal to 1 by root 3. Now, remember, at present, I don't know what is the value of 1 by root 3 in terms of tan. So now I have to find out the value of sin A cos C plus cos A sin C. I don't know the formula of sin A plus B also. So, but with the known identities of trigonometry, I have to find out. Means only with the help of the concepts of ratios and then Pythagoras law, I have to find out. I have to solve the problems. Now, according to the problem, let us take one is one side, another one is root 3, another side is root 3. Now find out the hypotenuse, which is square root of 1 plus root 3 whole square, which is root 4, nothing but 2. Now all the three sides are known, so you can find out sin A cos B, sorry, sin A cos A, sin C cos C. So sin A will be root 3 by 2 and cos C will be root 3 by 2. So similarly cos A will be 1 by 2 and sin C will be 1 by 2. So only simply opposite side by hypotenuse you can write, and adjacent side by hypotenuse you can write with respect to the reference angle, so that you are going to find out the sin A cos A sin C cos C. Now substitute in the formula, then we are getting 3 by 4 plus 1 by 4, which is 4 by 4, which is 1. Now see, which is the formula related to the sin A plus B. So where A is one angle is 30 degrees, another angle is 60 degrees. So total will be 30 plus 60 becomes 90. So sin 90 is 1. So that is how you can verify. So in the latter stages, once if you know so many formulas, you can simplify the problems in much simple way with less number of steps. But as of now, only with the help of only ratios of the different sides, we can evaluate, we can solve all these type of problems, whether it is related to the objective